Hi, my name is Mikkel, and in this last example we are going to combine the previous 4 examples into one. This is an example from a real case where installations were done and some went badly, but without a measuring device that could accurately measure the advancement ratio, rotation speed and proper torque, no one would have realized that some installations were incorrect and therefore resulted in a lower bearing capacity. So we are going to look at why we can't just rely on our torque measurement, even though it might be measured with a proper, isolated and calibrated instrument, and why we need to monitor the other parameters also during installation. The 4 piles here are all the same type, with a diameter of 76 mm and a T12 thread. They all had the same torque measurement of around 3,200 Nm during their last rotation. So when we static tested the first pile, which yielded a bearing capacity of 75 kN, one could quite easily think that piles 2, 3 and 4 would also have around 75 kN in bearing capacity because they had the same torque measurements during installation. But in reality, pile 2 actually had only 32 kN of bearing capacity. Pile 3 had 55 kN, and then pile 4 had a bearing capacity of 102 kN from the static load test. So looking at these tests, the big question is, why are there 4 piles of the same type, with the same torque measurements, presumably installed in the same soil, that have such different bearing capacity results? The reason why was in the measurement of the advancement ratio and speed. We can see the pile number 1 had an advancement ratio of 0.9 and a speed of 12 RPMs, which is a okay installation. Pile 2 had a poor installation with an advancement ratio of 0.5. But the fast installation hit the torque reduction. So the reduction in torque measurement from a bad installation gets cancelled out by the high speed at which the installation was done. Therefore, you cannot foresee the reduction in bearing capacity solely based on the torque. If we then look at pile number 3, it had an acceptable advance ratio just within the limits. It was installed at 20 RPMs, so compared to pile 1, the torque reduction from an advance ratio of 0.81 in this pile to 0.92 in pile 1 is hidden by the faster installation. Lastly, pile 4 had a much greater bearing capacity than pile 1, which was because it was installed in clay. However, you would normally see a reduction in torque during installation in clay. This pile was installed at 27 RPMs, whereas pile 1 was installed at only 12 RPMs. Therefore, the normally expected reduction in torque is again cancelled out by the faster rotation speed. So this example from a real case essentially states and proves what Aalborg University has found through research. You can't document screw piles solely based on torque. You also need an advancement ratio and rotation speed. This gives you full insight into what is happening during the installation and if you are hitting soil layers that weren't detected in the soil investigations. And then of course the last thing is, you can't measure torque with oil pressure. I hope you found this information useful and that it provided insights into the importance of correctly monitoring and documenting a screw pile project. Follow for more information, where we will look into other examples and important areas when using screw piles in your project.